Have you ever wondered how your phone can stream HD videos without buffering? Or how you can make crystal clear video calls while moving around the city? That's all thanks to 4G technology, the fourth generation of mobile communication, which completely revolutionized the way we connect and communicate. In this video, we'll explore what 4G really is, how it evolved from earlier generations, what makes it so powerful, and how it supports the applications we rely on every day, from video streaming to smart cities. Let's dive in and understand why 4G became the backbone of today's mobile internet. "4G stands for Fourth Generation Mobile Network Technology. It represents a major leap from previous generations by offering true broadband internet on mobile devices. While 3G allowed basic web browsing and media access, 4G introduced high-speed, always-on connectivity with data rates reaching up to 100 megabits per second for mobile users and up to 1 gigabit per second for stationary users. This speed enables us to watch HD and even 4K videos, use cloud services, play online games, and connect smart devices without delays. 4G also uses packet-switched, all-IP networks, meaning that all forms of communication, voice, video, and data, are transmitted as digital data packets. This makes communication more efficient and reliable compared to older, circuit-switch systems. To understand 4G, let's quickly revisit how we got here. 1G appeared in the 1980s. It was analog, designed only for voice calls, and had limited coverage and security. 2G, introduced in the 1990s, moved to digital signals. It allowed text messaging, SMS, and basic data transfer, using technologies like GSM and CDMA. 3G brought the mobile internet to life. It enabled multimedia services, web browsing, email, and video calling, but with lower data rates compared to today's needs. Then came 4G, offering true mobile broadband, IP-based architecture, and seamless global connectivity. With 4G, the internet became mobile, fast, and accessible, making smartphones an essential part of daily life. It laid the groundwork for everything from social media to cloud computing. 4G is designed to create an all-IP environment, where voice, video, and data are carried over the same infrastructure. It provides very high data rates, ranging from 100 megabits per second to 1 gigabit per second. Seamless handover between networks, allowing users to stay connected while moving. Global roaming, so the same device can operate across different regions. Quality of service, QoS features ensuring smooth performance for voice, streaming, and gaming applications. This makes 4G an ideal platform for both personal and industrial communication. Here are some standout features that make 4G powerful. Fully converged services. Supports internet, voice, and multimedia on a single network. Software-based upgrades. Easy to adapt and scale without replacing all hardware. Simple protocol architecture. Reduces latency and improves performance. High spectral efficiency. Uses radio spectrum more effectively, increasing capacity. Low cost per bit. Transferring data becomes cheaper for both providers and users. Low latency. Quick response time is perfect for real-time applications like gaming and video calls. These features make 4G not just faster, but also smarter and more efficient. The real power of 4G lies in how it transformed our daily lives and industries. Some key applications include traffic control and smart transportation systems, using connected sensors and cameras, telemedicine and online education, enabling real-time interaction between doctors, teachers, and students, video conferencing for global collaboration, virtual navigation and GPS, making location-based services accurate and reliable. Smart vehicles and IoT devices that share data in real time. Surveillance and public safety systems, such as cameras and traffic lights. In short, 4G is the foundation of today's connected world, powering everything from smartphones to smart cities. The shift from 3G to 4G was more than just speed. It changed how networks operate. 3G was partially circuit-switched, while 4G is fully packet-switched IP-based. 4G offers 10 times faster speeds, lower latency, and better security. 3G networks struggled with video streaming and high traffic loads, but 4G handles them effortlessly. 4G also allows HD voice VoLTE, giving crystal clear call quality. This is why 4G quickly replaced 3G as the global mobile standard. The benefits of 4G are numerous. Extremely high data rates for seamless browsing, streaming, and gaming. Stronger security and encryption, ensuring safer communication. Improved coverage and reliability, even in densely populated areas. Cost efficiency, lower cost per bit transmitted. Support for diverse applications from cloud services to IoT devices. Together, these advantages make 4G the foundation of the modern digital lifestyle. However, 4G also comes with a few challenges. High infrastructure cost. Upgrading from 3G to 4G required massive investment. Complex hardware. Devices and base stations need to handle more data and frequency bands. High power consumption. Both devices and networks use more energy, leading to faster battery drain. Despite these drawbacks, 4G remains one of the most efficient and widely used technologies today. 4G uses OFDM, orthogonal frequency division multiplexing, as its key technology. Instead of sending one high-speed data stream, OFDM divides it into many smaller subcarriers, each transmitting part of the data at a lower rate. This approach makes the signal resistant to interference and multipath fading, which is common in wireless communication. In terms of modulation, 4G uses digital schemes such as amplitude shift keying, ASK, frequency shift keying, FSK, and phase shift keying, PSK, or more advanced variants like QPSK and QAM. These techniques ensure efficient, stable, and high-quality data transmission, even over long distances. The architecture of a 4G network is simpler and more efficient than previous generations. It consists of three main components: user equipment, i.e. your smartphone, tablet, or modem; eNodeB, evolved eNodeB, the base station that handles all radio communications with the user; evolved packet core, EPC, the central network that manages data routing, mobility, authentication, and internet access. This flat architecture reduces delay, improves scalability, and supports millions of simultaneous connections efficiently. In conclusion, 4G technology has completely transformed wireless communication. It delivers fast, reliable, and flexible connectivity, enabling new innovations in healthcare, transportation, education, and entertainment. 4G not only improved how people communicate, it paved the way for 5G, where connectivity becomes even faster and smarter. As our world continues to evolve, 4G remains a strong foundation for the future of digital communication. Thanks for watching. If you found this explanation helpful, give it a thumbs up and subscribe for more videos on 5G, IoT, and next-generation networks. Comment below what topic you'd like to see next, and I'll see you in the next video.